So now moving on to the next presentation, we have Autowell. We have Ning Chen, who is a laboratory director at Autowell Technology. He is going to talk on TOPCon metallization and interconnection solutions from Autowell. Ning?
Yeah, thank you very much, Shab. So I share my screen. Yeah, can you see it?
Yeah.
Okay, yeah, thanks for introduction. My name is Ning Chen, I'm from Autowell. So today I'm going to present a metallization and interconnection solution from Autowell for TOPCon cell and modules. So a general outline. So first part regarding Autowell, then introduction of TOPCon. For metallization, I'll focus on screen printing lights, and interconnection, I'll focus on laser cutting stringers. Then finally, there's a summary page. Maybe some colleagues don't know, Autowell was founded in 2010, and its full name is Autowell Technology. So it's a well-known intelligent equipment manufacturer. So currently we have employee of over 4,000, and we including over 700 R&D person, and we have over 1,400 patents for our products. We already sold to over 40 countries and regions, and we have customer around world over 600 now. So for our business, as we are focusing on intelligent manufacturing system, including three areas: lithium iron battery, photovoltaic, and semiconductor. Especially for PV, we have a lot of business here. From ingot to module. For ingot, we have a crystal growth furnace. Wafer, we mainly have a wafer impact skin system. And for cell, which I'm going to talk about today, we have a firing passivation furnace and screen printed lights. Also, some new products are coming. For module, we have stringers, especially we have a big market share here. Also, we have some new machine for modules. So back to our topic today. For TOPCon, as already mentioned by other speakers. So according to RTRPV, we have market share this year expect to be 15%. According to PV InformLink, it's 27, I think even more this year. And for next year, it's even more aggressive from PV InformLink, over 60%. So we'll see the outcome next year. So I skipped the structure because everyone knows that. For cell process flow, or maybe including module part, I'm going to talk about the screen printing, which is backend of the solar cell light and the firing, and also IV testing sorting this part. And for the front end of the module part, it's also including laser cutting and soldering. For screen printing lights, is currently we have a DM or 5000 E 9000. It's our latest version of screen printing lights. So it is some features. Maybe I can show this picture. From the left to right, usually we have a wafer loader for screen print light, and for TOPCon cells, typically there are 4 screen printers. After each step, there will be dry furnace. So there will be 4 screen printer, then with 4 dry furnace. Then after all printing was done, then we have fire furnace. Then IV testing, usually integrated with EL, and then we have a wafer sorting or cell sorting sorter later. So I give some more details about our printers. So for Autowell, we have a special design, we call the full platform linear interactive printing module. So I could also show some images of from our patent. So there are 4 platforms. So with this 4 platform, one platform can be working on printing. The other 3 can working on load and loading. So with this, the process time is mainly decided by the printing time. So it can be very fast. So our currently cycle time for M10 wafers is 0.8 seconds. And also with this linear system, the alignment is quite good. For double printing, it's less than 60 micrometers. It, of course, is also suitable for 5-line printing. So with 0.6 seconds cycle time, you can calculate the throughput is 9,000 wafer per hour. So usually from late finger, you can see this also from our TOPCon PV. So for printing lines, it's usually the throughput compared with that machine in the middle. So we are not as high throughput as other machines. But with our technology, you can see the right finger. This Autowell can reach maybe already 4 years ahead. So we can achieve the 9,000 even more now. So currently the screen printing is can be comparable with inline chemical process tools. Then the next step after screen printing is firing. So actually we have our machine is firing and passivation integrated. So it's not only the fire furnace, but also there is module. We can do passivation or hydrogenation. So it can increase, especially for compared with standard firing. We have efficiency increment for TOPCon. That's what we measured before, 0.2 or even up to 0.8 in the old times. So the machines with pressures, stable temperature control. So it's, by the way, Autowell is actually the first equipment supplier to introduce such furnace to the market. Originally, it's used for P-type PERC. Then after that, we found the increase. It also can be used for N-type TOPCon. So now it's a standard machine for TOPCon solar cell lines. So if you look at the loss of the TOPCon cells, this is the fingers from ISFH. So the main loss now with good passivation from the rear is now the TOPCon cell or standard TOPCon cell is from the front side. So related with metallization, it's mainly from front contact resistance, front contact recombination, and front finger shading. So we can improve our printing line by doing better. For example, we can do laser enhanced metallization. For this is our new process and equipment introduced to the market. So with this tool or process, we can improve front contact resistance and front recombination. So we measured around 0.2 or to 0.3 absolute efficiency gain. We can benefit from such process or equipments. Also, the efficiency distribution is better. So you can see the error image from the bottom. So for baseline, the final error image like this. Then with a special paste before limp process, we have not good content, but after limp process, you see a brighter error image than the baseline. And for this process, you can either do offline or inline. With inline, you can integrate in between passivation furnace and IV testing and solder. So you can also do offline, and then you need another loader. So you can do after loading the wafers and do the limp process, then do IV testing and sorting. So after the solar cell made, we also have a solution for cell packaging and logistics. Actually, for current cell line, it's the other process is quite automatic. For wafer packaging, it's usually need a lot of people to do that. But with packaging automatic solution and also PV logistics, mainly from you load your wafer to then to do the packaging, you can save a lot of manpower. So for interconnection, actually we have a new approach. Actually, you can connect the scrutiny line directly to the interconnection or soldering line. So we propose a new approach. You can do the back-end process, which is the screen printing, and then you can do the laser cutting directly after screen printing line, and after laser cutting, you can do the soldering. So by doing this, you have a half-cut cell soldering, then you have better control of the parameters, and also you ignore the, especially when you do manually, then you don't have to do wafer packaging or solar cell packaging. For laser cutting, we have a very stable tool actually. We introduce soft touch for loading and unloading, and for thin wafers, we have a intelligent cutting technology for 120 micrometers wafer. Its breakage is very low, only 3 wafers out of 10,000. We also optimized the laser cutting for lasers, especially the optical path and also the water. So we have for laser cutting, we are using laser damage free. Also, it's can use either water or no water solution. And especially we have some protection, additional protection for loading and unloading to avoiding scratch. So the final interconnection step is stringer. So our latest product is AM15K. So it's very high speed stringer with throughput more than 10,000 half cells per hour. So currently the industry standards is SMBB super multi-busbar, but later it can all be also compatible with zero busbar solution. So we also have, because also mentioned by other colleagues, we have rectangle wafers, also cells now. So we also have a special solution for such customers. So after laser cutting, we can sort it the smaller wafer and small wafer and big cell separately to different stringers. So by doing that, then in the same line, you can produce different format modules. So last, I address some maybe my main concerns. One of the concerns is silver consumption for TOPCon cells. Currently, it's like ITR PV mentioned about 100, maybe 40 to 50 milligram per cell. And according to our knowledge, currently actually for the leading TOPCon cell producers is around 110 to 120 milligram. And the easiest way actually you can ignore busbar, can reduce the silver from busbar. You can do either silverless or silver-free materials. Also, another solution you can do from interconnection is you can use busbar solution. It's mainly we use solution from for stringers. So unfortunately, I don't have time for today for introduce more about this topic, but we already have some solution for that. For screen printing, and another issue or concern is about the age recognition. So especially for high VOC or high efficiency solar cells, the after laser cut, the recombination loss is quite high. So for heat rejection, they are already using half-cut cells or wafers at the beginning. So it's also an option for TOPCon cells. So for Autowell, we also have a half-cell screen printer ready for mass production. Okay, in summary, in slides, I merely introduced the metallization and interconnection solution for TOPCon cells. And for screen print line, we have high throughput and high accuracy screen printer. We also have a special designed firing and passivation furnace. And we have a new process equipment with laser intense metallization, called LID. So also we have for interconnection, we have a laser cutting and sorting process with some new features. Other improvement in the future will be busbarless or zero busbar module stringers and half-cut cell printers. They are ready for mass production. Thank you very much.
Okay, thanks a lot, Ning. So I have one question. So you showed that you have a screen printing solution for TOPCon. So where do you see the mainstream finger width in the TOPCon production? The screen opening and finger width.
Currently, about 20 after printing.
20
Screen,
microns.
Yeah, 20 micrometers. Screen opening, I don't have data from customer, but we can print for opening. We have maybe 18 or around 18 micrometers.
And regarding your zero bus bar solution, so is it ready, or are you still in the development phase?
Maybe my module colleague can answer you more. We are actually in development. We have different approaches, but for marketing, it's really depends on the customer needs. If you need a different solution, you can get from Autowell.
Okay, thank you very much.